Welcome to the I Can't Sleep podcast, where I read random articles from across the web to bore you to sleep with my soothing voice. I'm your host, Benjamin Foster. Today's episode is from a Wikipedia article titled Logistics. Logistics is generally the detailed organization and implementation of a complex operation. In a general business sense, logistics manages the flow of goods between the point of origin and the point of consumption to meet the requirements of customers or corporations. The resources managed in logistics may include tangible goods, such as materials, equipment, and supplies, as well as food and other consumable items. In military science, logistics is concerned with maintaining army supply lines while disrupting those of the enemy, since an armed force without resources and transportation is defenseless. Military logistics was already practiced in the ancient world, and as the modern military has a significant need for logistics solutions, advanced implementations have been developed. In military logistics officers manage how and when to move resources to the places they are needed. Logistics management is the part of supply chain management and supply chain engineering that plans, implements, and controls the efficient, effective forward and reverse flow and storage of goods, services, and related information between the point of origin and point of consumption to meet customers' requirements. The complexity of logistics can be modeled, analyzed, visualized, and optimized by dedicated simulation software. The minimization of the use of resources is a common motivation in all logistics fields. A professional working in the field of logistics management is called a logistician. Nomenclature. The term logistics is attested in English from 1846 and is from French, logistique, where it was either coined or popularized by Swiss military officer and writer Antoine Henry Jomini, who defined it in his summary of the art of war. The term appears in the 1830 edition, then titled Analytic Table, and Jomini explains that it is derived from French logis, lodgings, cognate from English lodge. In the term's French, Maréchal des Logis. The term appears in the 1830 edition, then titled Analytic Table, and Jomini explains that it is derived from French logis, lodgings, cognate to English lodge. The term is credited to Jomini, and the term and its etymology criticized by Georges de Chambray in 1832. Writing, logistic. This word appears to me to be completely new, as I have not yet seen it anywhere in military literature. He appears to derive it from the word lodgings, a peculiar etymology. Chambray also notes that the term logistique was present in the French dictionary as a synonym for algebra. The French word logistique is a homonym of the existing mathematical term from ancient Greek, logistikos, a traditional division of Greek mathematics. The mathematical term is presumably the origin of the term logistic and logistic growth and related terms. Some sources give this instead as the source of logistics, either ignorant of Jomini's statement that it was derived from logis, or dubious and instead believing it was in fact of Greek origin, or influenced by the existing term of Greek origin. Definition. Jomini originally defined logistics as the art of well ordering the functionings of an army of well combining the order of troops in columns, the times of their departure, their itinerary, the means of communication necessary to assure their arrival at a named point. The Oxford English Dictionary defines logistics as the branch of military science relating to procuring, maintaining, and transporting material, personnel, and facilities. However, the New Oxford American Dictionary defines logistics as the detailed coordination of a complex operation involving many people, facilities, or supplies. And the Oxford Dictionary Online defines it as the detailed organization and implementation of a complex operation. As such, logistics is commonly seen as a branch of engineering that creates people systems rather than machine systems. According to the Council of Supply Chain Management Professionals, previously the Council of Logistics Management, logistics is the process of planning, implementing, and controlling procedures for the efficient and effective transportation and storage of goods, including services and related information from the point of origin to the point of consumption, for the purpose of conforming to customer requirements, and includes inbound, outbound, internal, and external movements. Academics and practitioners traditionally refer to the terms operations or production management when referring to physical transformations taking place in a single business location, factory, restaurant, or even bank clerking, and reserve the term logistics for activities related to distribution, that is, moving products on the territory. Managing a distribution center is seen, therefore, as pertaining to the realm of logistics, since, while in theory, the products made by a factory are ready for consumption, they still need to be moved along the distribution network, according to some logic, and the distribution center aggregates and processes orders coming from different areas of the territory. That being said, from a modeling perspective, there are similarities between operations management and logistics, and companies sometimes use hybrid professionals with, for example, a director of operations or a logistics officer working on similar problems. Furthermore, the term supply chain management originally referred to, among other issues, having an integrated vision of both production and logistics from point of origin to point of production. All these terms may suffer from semantic changes as a side effect of advertising. Logistics activities and fields. Inbound logistics is one of the primary processes of logistics, concentrating on purchasing and arranging the inbound movement of materials, parts, or unfinished inventory from suppliers to manufacturing or assembly plants, warehouses, or retail stores. Outbound logistics is the process related to the storage and movement of the final product, and the related information flows from the end of the production line to the end user. Given the services performed by logisticians, the main fields of logistics can be broken down as follows: procurement logistics, distribution logistics, after-sales logistics, disposal logistics, reverse logistics, green logistics, global logistics, domestics logistics, concierge service, reliability, availability, and maintainability, asset control logistics, point of sale material logistics, emergency logistics, production logistics, construction logistics, capital project logistics, digital logistics, humanitarian logistics. Procurement logistics consist of activities such as market research, requirements planning, make or buy decisions, supplier management, ordering, and order controlling. The targets in procurement logistics might be contradictory, maximizing efficiency by concentrating on core competencies, outsourcing while maintaining the autonomy of the company, or minimizing procurement costs while maximizing security within the supply process. Advanced logistics consists of the activities required to set up or establish a plan for logistics activities to occur. Global logistics is technically the process of managing the flow of goods through what is called a supply chain, from its place of production to other parts of the world. This often requires an intermodal transport system, transport via ocean, air, rail, and truck. The effectiveness of global logistics is measured in the Logistics Performance Index. Distribution logistics has as main tasks the delivery of the finished products to the customer. It consists of order processing, warehousing, and transportation. Distribution logistics is necessary because the time, place, and quantity of production differ with the time, place, and quantity of consumption. Disposal logistics has its main function to reduce logistics costs and enhance services related to the disposal of waste produced during the operation of a business. Reverse logistics denotes all those operations related to the reuse of products and materials. The reverse logistics process includes the management and the sale of surpluses, as well as products being returned to vendors from buyers. Reverse logistics stands for all operations related to the reuse of products and materials. It is the process of planning, implementing, and controlling the efficient, cost-effective flow of raw materials, in-process inventory, finished goods, and related information from the point of consumption to the point of origin for the purpose of recapturing value or proper disposal. More precisely, reverse logistics is the process of moving goods from their typical final destination for the purpose of capturing value or proper disposal. The opposite of reverse logistics is forward logistics. Green logistics describes all attempts to measure and minimize the ecological impact of logistics activities. This includes all activities of the forward and reverse flows. This can be achieved through intermodal freight transport, path optimization, vehicle saturation, and city logistics. RAM logistics combine both business logistics and military logistics, since it is concerned with highly complicated technological systems for which reliability, availability, and maintainability are essential. Examples: weapon systems and military supercomputers. Asset control logistics. Companies in the retail channels, both organized retailers and suppliers, often deploy assets required for the display, preservation, promotion of their products. Some examples are refrigerators, stands, display monitors, seasonal equipment, poster stands, and frames. Emergency logistics or humanitarian logistics is a term used by the logistics supply chain and manufacturing industries to denote specific time-critical modes of transport used to move goods or rapidly in the event of an emergency. The reason for enlisting emergency logistics services could be a production delay or anticipated production delay, or an urgent need for specialized equipment to prevent events such as aircraft being grounded, also known as aircraft on ground, ships being delayed, or telecommunications failure. Humanitarian logistics involves governments, the military, aid agencies, donors, non-governmental organizations, and emergency logistics services are typically sourced from a specialist provider. The term production logistics describes logistic processes within a value-adding system. Example, factory, or a mine. Production logistics aims to ensure that each machine and workstation receives the right product in the right quantity and quality at the right time. The concern is with production, testing, and transportation, storage, and supply. Production logistics can operate in existing as well as new plants. Since manufacturing in an existing plant is a constantly changing process, machines are exchanged and new ones added, which gives the opportunity to improve the production logistics system accordingly. Production logistics provides the means to achieve customer response and capital efficiency. Production logistics becomes more important with decreasing batch sizes. In many industries, e.g., mobile phones, the short-term goal is a branch size of 1, allowing even a single customer's demand to be fulfilled efficiently. Track and tracing, which is an essential part of production logistics due to product safety and reliability issues, is also gaining importance, especially in the automotive and medical industries. Construction logistics has been employed by civilizations for thousands of years, as the various human civilizations tried to build the best possible works of construction for living and protection. Now construction logistics has emerged as a vital part of construction. In the past few years, construction logistics has emerged as a different field of knowledge and study within the subject of supply chain management and logistics. Concept of 7 R's is a popular concept used to enforce best practices in logistics management, which consists of the following: right product, including the right information about it, at right quantity, right time, right condition, right place to the right customer, with the right financial resources. Military logistics. In military science, maintaining one's supply lines while disrupting those of the enemy is a crucial, some would say the most crucial, element of military strategy, since an armed force without resources and transportation is defenseless. The historical leaders Hannibal, Alexander the Great, and the Duke of Wellington are considered to have been logistical geniuses. Alexander's expedition benefited considerably from his meticulous attention to the provisioning of his army. Hannibal is credited to have taught logistics to the Romans during the Punic Wars, and the success of the Anglo-Portuguese army in the Peninsula War was due to the effectiveness of Wellington's supply system, despite the numerical disadvantage. The defeat of the British in the American War of Independence and the defeat of the Axis in the African theater of World War II are attributed by some scholars to logistical failures. Militaries have a significant need for logistics solutions, and so have developed advanced implementations. Integrated Logistics Support, ILS, is a discipline used in military industries to ensure an easily supportable system with a robust customer service logistic concept at the lowest cost, and in line with often high reliability, availability, maintainability, and other requirements as defined for the project. In military logistics, logistics officers manage how and when to move resources to the places they are needed. Supply chain management in military logistics often deals with a number of variables in predicting costs, deterioration, consumption, and future demand. The United States Armed Forces categorical supply classification was developed in such a way that categories of supply with similar consumption variables are grouped together for planning purposes. For instance, peacetime consumption of ammunition and fuel will be considerably lower than wartime consumption of these items, whereas other classes of supply, such as subsistence and clothing, have a relatively consistent consumption rate regardless of war or peace. Some classes of supply have a linear demand relationship. As more troops are added, more supply items are needed. Or as more equipment is used, more fuel and ammunition are consumed. Other classes of supply must consider a third variable besides usage and quantity: time. As equipment ages, more and more repair parts are needed over time, even when usage and quantity stay consistent. By recording and analyzing these trends over time and applying them to future scenarios, the U.S. Armed Forces can accurately supply troops with the items necessary at the precise moment they are needed. History has shown that good logistical planning creates a lean and efficient fighting force. The lack thereof can lead to a clunky, slow, and ill-equipped force with too much or too little supply. Business logistics. One definition of business logistics speaks of having the right item in the right quantity, at the right time, at the right place, for the right price, in the right condition, to the right customer. Business logistics incorporates all industry sectors and aims to manage the fruition of project life cycles, supply chains, and resultant efficiencies. The term business logistics has evolved since the 1960s due to the increasing complexity of supplying businesses with materials and shipping out products in an increasingly globalized supply chain, leading to a call for professionals called supply chain logisticians. In business, logistics may have either an internal focus, inbound logistics, or an external focus, outbound logistics, covering the flow and storage of materials from point of origin to point of consumption. The main functions of a qualified logistician include inventory management, purchasing, transportation, warehousing, consultation, and the organizing and planning of these activities. Logisticians combine professional knowledge of each of these functions to coordinate resources in an organization. There are two fundamentally different forms of logistics. One optimizes a steady flow of material through a network of transport links and storage nodes, while the other coordinates a sequence of resources to carry out some project, e.g., restructuring a warehouse. Nodes of a distribution network. The nodes of a distribution network include factories where products are manufactured or assembled, a depot or deposit, a standard type of warehouse for storing merchandise, high level of inventory, distribution centers for ordering, processing, and order fulfillment, low level of inventory, and also for receiving returning items from clients. Typically, distribution centers are way stations for products to be dispersed further down the supply chain. They usually do not ship inventory directly to customers, whereas fulfillment centers do. Transit points for cross-docking activities, which consist of reassembling cargo units based on deliveries scheduled, only moving merchandise. Traditional mom and pop retail stores, modern supermarkets, hypermarkets, discount stores, or also voluntary chains, consumers cooperative, groups of consumers with collective buying power. Note that subsidiaries will be mostly owned by another company and franchisors, although using other company brands actually own the point of sale. There may be some intermediaries operating for representative matters between nodes, such as sales agents or brokers. Logistic families and metrics. A logistic family is a set of products that share a common characteristic: weight and volumetric characteristics, physical storing needs, temperature, radiation, handling needs, order frequency, packaging size, etc. The following metrics may be used by the company to organize its products in different families. Physical metrics used to evaluate inventory systems, including stocking capacity, selectivity, superficial use, volumetric use, transport capacity use. Monetary metrics used include space holding costs, building, shelving, and services, and handling costs, people, handling machinery, energy, and maintenance. Other metrics may present themselves in both physical or monetary form, such as the standard inventory turnover. Handling and order processing. Unit loads are combinations of individual items which are moved by handling systems, usually employing a pallet of normed dimensions. Handling systems include trans-pallet handlers, counterweight handler, retractable mast handler, bilateral handlers, trilateral handlers, AGV, and other handlers. Storage systems include pile stocking, cell racks, either static or movable, cantilever racks, and gravity racks. Order processing is a sequential process involving processing withdrawal list, picking selective removal of items from loading units, sorting, assembling items based on the destination, packaging information, weighting, labeling, and packaging, order consolidation, gathering packages into loading units for transportation, control, and bill of landing. Picking can be both manual or automated. Manual picking can be both man-to-goods, i.e. operator using a cart or conveyor belt, or goods-to-man, i.e. the operator benefiting from the presence of a mini-load ASRS, vertical or horizontal carousel, or from an automatic vertical storage system, AVSS. Automatic picking is done either with dispensers or depalletizing robots. Sorting can be done manually through carts or conveyor belts, or automatically through sorters. Transportation. Cargo, i.e. merchandise being transported, can be moved through a variety of transportation means and is organized in different shipment categories. Unit loads are usually assembled into higher standardized units such as ISO containers, swap bodies, or semi-trailers. Especially for very long distances, product transportation will likely benefit from using different transportation means: multimodal transport, intermodal transport, no handling, and combined transport, minimal road transport. When moving cargo, typical constraints are maximum weight and volume. Operators involved in transportation include all train, road vehicles, boats, airplanes companies, couriers, freight forwarders, and multimodal transport operators. Merchandise being transported internationally is usually subject to the Incoterms standards issued by the International Chamber of Commerce. Configuration and management. Similarly to production systems, logistics systems need to be properly configured and managed. Actually, a number of methodologies have been directly borrowed from operations management, such as using economic order quantity models for managing inventory in the nodes of the network. Distribution resource planning, DRP, is similar to MRP, except that it doesn't concern activities inside the nodes of the network, but planning distribution when moving goods through the links of the network. Traditionally, in logistics configuration may be at the level of the warehouse nodes or at level of the distribution system network. Regarding a single warehouse, besides the issue of designing and building the warehouse, configuration means solving a number of interrelated technical economic problems. Dimensioning rack cells, choosing a palletizing method, manual or through robots, rack dimensioning and design, number of racks, number of typology of retrieval systems, e.g., stacker cranes. Some important constraints have to be satisfied: fork and load beams, resistance to bending, and proper placement of sprinklers. Although picking is more of a tactical planning decision than a configuration problem, it is important to take it into account when deciding the layout of the racks inside the warehouse and buying tools such as handlers and motorized carts, since once those decisions are taken, they will work as constraints when managing the warehouse. The same reasoning for sorting when designing the conveyor system or installing automatic dispensers. Configuration at the level of the distribution system concerns primarily the problem of location of the nodes in geographic space and distribution of capacity among the nodes. The first may be referred to as facility location with the special case of site selection, while the latter to as capacity allocation. The problem of outsourcing typically arises at this level. The nodes of a supply chain are very rarely owned by a single enterprise. Distribution networks can be characterized by numbers of levels, namely the number of intermediary nodes between supplier and consumer. Direct store delivery, i.e., 0 levels. 1-level network, central warehouse. 2-level network, central and peripheral warehouses. This distinction is more useful for modeling purposes, but it relates also to a tactical decision regarding safety stocks. Considering a 2-level network, if safety inventory is kept only in peripheral warehouses, then it is called a dependent system from suppliers. If safety inventory is distributed among central and peripheral warehouses, it is called an independent system from suppliers. Transportation from producer to the second level is called primary transportation. From the second level to a consumer is called secondary transportation. Although configuring a distribution network from 0 is possible, logisticians usually have to deal with restructuring existing networks due to presence of an array of factors: changing demand, product or process innovation, opportunities for outsourcing, change of government policy toward trade barriers. Innovation in transportation means both vehicles or thoroughfares, the introduction of regulations, notably those regarding pollution, and availability of ICT supporting systems, e.g., ERP or e-commerce. Once a logistics system is configured, management, meaning tactical decisions, takes place once again at the level of the warehouse and of the distribution network. Decisions have to be made under a set of constraints: internal, such as using the available infrastructure, or external, such as complying with the given product shelf lives, and expiration dates. At the warehouse level, the logistician must decide how to distribute merchandise over the racks. 3 basic situations are traditionally considered: shared storage, dedicated storage, rack space reserved for specific merchandise, and class-based storage. Class meaning merchandise organized into different areas according to their access index. Picking efficiency varies greatly depending on the situation. For a man-to-goods situation, a distinction is carried out between high-level picking, vertical component significant, and low-level picking, vertical component insignificant. A number of tactical decisions regarding picking must be made. Routing path. Standard alternatives include transversal routing, return routing, midpoint routing, and largest gap return routing. Replenishment method. Standard alternatives include equal space supply for each product class and equal time supply for each product class. Picking logic. Order picking versus batch picking. At the level of the distribution network, Tactical decisions involve mainly inventory control and delivery path optimization. Note that the logistician may be required to manage the reverse flow along the forward flow. Warehouse management system and control. Although there is some overlap in functionality, warehouse management systems, WMS, can differ significantly from warehouse control systems, WCS. Simply put, a WMS plans a weekly activity forecast based on such factors as statistics and trends, whereas a WCS acts like a floor supervisor, working in real time to get the job done by the most effective means. For instance, a WMS can tell the system that it is going to need 5 of stock keeping unit SKU A and 5 of SKU B hours in advance. But by the time it acts, other considerations may have come into play, or there could be a logjam on a conveyor. A WCS can prevent that problem by working in real time and adapting to the situation by making a last-minute decision based on current activity and operational status. Working synergistically, WMS and WCS can resolve these issues and maximize efficiency for companies that rely on the effective operation of their warehouse or distribution center.